Good afternoon everyone. Today I am going to discuss about database management systems. This is a 6th semester core course and it is one of the most fundamental course in computer science. So let's try to see what do you mean by a database system. So all of you have used a database system whether you like it or not. So the best example I can give you is in your learning management system Moodle. The backend has a database. Similarly, say in your train reservation, the IRCTC, that also has a database. Similarly, banking, they are transactions, but they are nevertheless they are databases. So all these are examples of database systems. Now, on a high level, how does a database management system work? So you have application program. So this is the front end that is interfacing with the user. So for instance, in your Moodle, it's your HTML, the web page of HTML that is interfacing with you. Then you have the query, the database software. So for instance, in Moodle, we have what is known as a MySQL, My Structured Query Language database. And then below that, the real data is being stored. So it is stored on the disk. So for instance, in your laptop, you have the disk. So you can see at the top, we have the application program. In this case, the Moodle application that's interfacing. Then we have MySQL, which is taking queries from you and getting data from it. And then you have the actual storage of data. Now, there are very good lots of databases. Although it's the WWW web is filled with databases. For instance, bank, Axis Bank, HDFC Bank, whatever you go, all those are databases. Railway, IRCTC, that's a database. LMS or Moodle, the one that's used to host our courses, that's database. Library, Koha, that is also database. Similarly, in a big data setup, also you have what is known as a NoSQL. It's slightly different from MySQL, but it's slightly different. Typically, all database systems store what is known as metadata. That is data that is used to uniquely identify the database. So you have what are known as database definitions or descriptive information. Let's just take a small look at a simple database. So this is a student database. So what do you have in a student database? Obviously, the student name, the student, the USN, the USN number, the class, and the major, the degree, the stream that he is in. So this is one example of a database. It's a table. It's a student table. Similarly, you have a course table. What do you have in the course table? You have the course name, the course number. For instance, our database course number is 22 ISD 62. The credit hours, for instance, in our course, the credit hours is in fact 3 hours, and then you have the department, which is ISC. Similarly, you have a section, within a section, how the course looks like, and then you get the grade report. This is at the end of the course. So what do you find here? You have rows. So for instance, here you have 4 rows and 4 columns. So basically, when you structure a database, you're structuring it in terms of rows and columns. So the database that uses rows and columns is known as a relational database. Now let's come to what are the, so as I told you, there are 5 tables. Student, I have shown you that was a course, section, grade report and prerequisites. Then you have it's not just sufficient that you specify the data, the table. You also need to specify the data type of each data element. If you go back, for instance, the student name, it is ASCII characters. Similarly, the student number is in fact integer, it's a number. Class is also a number. And then the major, which is the program that you are in, that is also a string or a character, ASCII character. So you store in the database all these things, data type of each data element. So for instance, name of the student is a string, student number is in an integer. Similarly, it's interesting to note that all these tables are related somewhat to each other. So for instance, you can take, let's take CS1310. You can see here. So this is part of a section. Now that section is 92. The section identifier is 92. Now you can see CS1310 is also here. It's in the course. So what is the name of the course? It's Introduction to Computer Science, which is 4-hour credit, and it is from the department. And the course number is CS1310. Now this you're referencing here. So you can see there is a dependency between different tables. So if you are supposing you change some value here, you will have to change it here also. So this is the way in which the tables are organized. Then you have what are known as database queries. So what do you mean by queries? So for instance, if I want to know how many students in the database class have an attendance of greater than 85%, that is in fact, I'll convert it into a query and query the database. So for instance, you continue as a database and you query the continue for the database. For instance, you can, if you want to know what is the marks of Smith, some student named Smith, if you go back, so you have Smith here and he is in class 1. So if you want to know that, you query the database. So this is the way in which you retrieve the details of the data of a particular student. It can be anything. You can retrieve the details of a course. For instance, you can even write queries that tell you how many students have passed or how many students have failed. That is again a MySQL query. So for instance, you can have another query which lists the number of students who took some course name database. So if you want to list that, that is again a database query. Similarly, prerequisites. For instance, database doesn't need any prerequisite, but if there is a prerequisite, you can write it again as a query. Now, how do you design the database? So first and foremost, you need to have a requirement. How does your data need to be spread out? So for that, you need to have a conceptual design. How do you design the database? Then you have the logical design, which is implemented in the commercial database management system. And then you have the physical design, which is basically storing the data. So you go through these three phases: conceptual design, logical design, and physical design. What are the characteristics of database? So by nature, the database systems are self-describing. So for instance, if you go back, here if you just look at the table, you know what the data is. So if you look at this table, you know it's a student database. You can see as name, student number, class, major. So this is what is known as a self-describing database. Similarly, course, you know course name. If you just see the database, you know what the database is storing. This is known as self-describing nature of the course. Okay.